Welcome to another video, and let's solve this nice exponent problem for the value of x. So given 16 to the power x equals x to the power of 8. So let's see how to solve this problem. If we are given 16 to the power of x, so by making both sides having 1 over x, that is, we raised both sides by 1 divided by x. And doing that, we know that the x here cancel this, and we are going to have this as 16 equals x to the power of 8 all raised to the power of 1 divided by x. Note that in this, if you apply these rules, let's say a raised to the power m all raised to the power n, this is equivalent to a raised to the power of mn, and we can still have it as a to the power of n all raised to the power m. So let's apply this in the steps we have. 16 equals a raised to the power 1 over x all raised to the power of 8. Again, we are going to raise both sides by 1 over 8. Then we have this, and the other side also have x to the power of 1 over x raised to the power 8 and all raised to the power 1 divided by 8. 8 cancelled 8, and the left hand side of this is 16 to the power of 1 over 8 equals x raised to the power 1 divided by x. So on getting to this stage, I'm going to do two different things because there is no one solution for this. So we have like two or more solutions. So for the case 1, for this 16, if I change it to exponent form of base 2, that is 2 to the power of 4 raised to the power of 1 divided by 8 equals x raised to the power 1 over x. And 4 will go in 8 in 2 times. So therefore we have 2, we are going to have 2 to the power of 1 divided by 2 equals x to the power of 1 over x. And we can conclude that if the base equivalents to the base, the power also equivalents to the power. So from the base, we can see that x equals 2, and from the power as well, which is 1 divided by 2 equals 1 divided by x. As if we cross multiply, we have x equals 2, which proves that x equals 2 is the value of x for the first case. And if we try to look at the second case in other way around, that from the steps of when we have 16 to the power of 1 over 8 equals x to the power of 1 divided by x. If I decide to change this 16 to 4 to the power 2, so which is still the same thing as 16, all raised to the power 1 over 8 equals x raised to the power 1 over x. Then 2 will go in 1 over 8 in 4 times, and we are going to have 4 to the power of 1 divided by 4 equals x to the power of 1 over x. And we conclude that x equals 4 is the solution to this problem. And note that I only solve for the integer solution for this. So we can also see some solutions by applying the Lambert rules. Alright, if x has been gotten, let's try to verify if these two roots satisfy this problem. For the first one, which is at x equals 2, given that 16 to the power x equals x raised to the power 8. Then if x equals 2, anywhere we see x, we replace it with 2. Therefore, we have 16 to the power 2 equals 2 to the power of 8. And looking at these two sides, so they are equal, or we can proceed as, so this can be, 8 can bring into 4.2, and by applying the rule of exponents I applied above, So the right hand side of this equation can become 16 all raised to the power of 2. So which proves that x equals to satisfy this. And at x equals 4, it's still going to replace anywhere we see x, we replace it with 4. That is 16 to the power of 4 equals 4 to the power of 8. And we can also change the base of, let's say, let me deal with the left hand side. Suppose I have this as, all right, so let's say I use 4 raised to the power 2, because 4 raised to the power 2 is 16, then all raised to the power 4 equals 4 to the power of 8. And 4 raised to the power 2 is just like if you have 2 times 4, that is 8. So 4 raised to the power 8 equals 4 raised to the power 8. So which also shows that the x equals 4 satisfy this problem. And this is how to solve this. So we can give a final conclusion in front of this question as 2, 4 is the two roots. Thanks for watching, and please don't forget to subscribe to this channel for more exciting problem like this. I will see you in the next class. Never stop learning. Bye bye.